Hello, this is a 3 series video on factoring polynomials. Grade 9, grade 10, grade 11 students can get great help from here. Okay. Now we will understand the technique of factoring, which is very important in solving algebraic problems. So factors is a term which you are familiar with. When I say 2 times 5 is 10, then 2 and 5 are factors of 10. So basically we are trying to write the things in product form. That is factoring. So we will see how to do it with simple examples to start with. Okay, let me take an example of, we'll first do common factors. So we will have 3 different groups in it. One, you can do factoring by common factors. Second, factoring by grouping. Third, we will consider trinomials. And in trinomials, we will see different techniques of factoring. Okay, common factors. Let's take a very simple example. Let's say 2x plus 10. Now, in this expression, 2 is coefficient of x. X is a variable. And this expression has got 2 terms. And therefore, this is also called as binomial. When there is only one term, then is called monomial. And when there are 2 terms, it's called binomial. Okay, this is sum of 2 terms. So let's see common factors. In this case, there is no variable in this side. The factors of the constant and the coefficient of x are just 2. How about 10? The factors of 10 are 2 and 5. So we see that 2 is common. Therefore, we can write this as equal to, we can factor out 2. This is what we meant by saying factoring. So we can factor out 2. Once we do that, then we need to divide both by 2 to write what goes into the parenthesis. So when you divide 2x by 2, you get just the variable x. Plus, this sign goes as it is, since outside is positive 2. And 10 divided by 2 is 5. So this is how normal process of factoring will be done. And you see, on this side we have a sum, right? And what do you get here? Product. So whenever you convert sum into product, we are actually going through the process of factoring. And now, how many terms? Those two sum things have been converted into one product term. Do you see that? Now let me take you few more examples just to help you understand this common factoring process. So let's write an expression like this: 4x square y square minus 20 xy square. Okay, this is again a binomial, correct? You understand? I'm trying to get you these terms, monomial, binomial, polynomial, in your mind. You need to look into my another video for the details for that. Okay, now let's check the coefficients of the variables. The coefficients are 4 and 20. So let's factor 4 and 20. Well, we can write 20 as 4 times 5. Well, that means 4 is common, right? Here we have 4. So 4 is common. Correct. Now, x square y square is kind of x times y times y. And here we have xy square. We can write this as x y square. Is it okay? Now, 2y gives me y square. So what are commons? X is common, y is common, the second y is also common. So common factoring means whichever factors are common, club them and bring them out. So we can bring 4xy square. So 4xy square is the common factor between these 2 terms of our binomial, correct? Let's put it out and open the brackets. Divide 1 by 1 both the terms and write inside, maintaining the sign. Why the sign is maintained? Because the common factor has a plus sign. If I take minus outside, then this sign will interchange, correct? So when you divide 4 by 4, you get 1. When you divide x square by x, you get x. Y square by y square is 1. So just x here. Minus 20 divided by 4 is 5. 5. And we have taken x, y square as our common factor. So we are left with 5 here, correct? So this expression, this binomial is equal to 4xy square times x minus 5. Do you see that? We have again converted this sum form. Why am I saying sum? Negative is also sum of negative number, right? Reciprocal of plus, correct? So addition and subtraction, we call it like sum, and multiplication and division as product in general, because dividing by 2 is as good as multiplying by half. Remember that, okay? Let me take one more example, which is kind of slightly different but similar, okay? Let's say we have terms like this time. 10y x minus 5 plus 7 times x minus 5. Well, in this case, the first term itself is product of two things, where one part is common. Do you see that? So, common factoring means factor out the common things. So, what are common here? X minus 5. So, let's bring that out. X minus 5, and in the bracket, we are left with the rest of the terms. When you divide this by x minus 5, you are left with 10y. 10y plus, and here 7, right, equal to. So, whenever you do this process of factoring, you should not forget to write equal to. It helps, to understand that this is equal to the previous problem. Do you understand? Now I'll give you some problems which you can try on your own, okay? For example, try these problems. 12 minus 4x. I've just reversed it, okay? And you can try this. X minus 4 times 2 times x minus 4 square. And let me write another problem for you. 7x square minus 21x. Now, the process, you remember, is just see. These are your leading coefficients. Check for the common factors. Here, 4 is the common factor. Here, x minus 4 is the common factor. Do you see? I forgot to write sign between. Okay, so this is your question 1, question 2, and this is your question 3. Okay, now let's look into another technique of factoring, and that is factoring by grouping. So sometimes it is not very obvious that these are the terms and they can be factored out. Now let me take an example where we will teach you how to first group them or look for groups with common factors. So here, this is a simple example. Here we have 4 terms, not 2 this time, 4 terms. Now we'll try to work out with this polynomial of 4 terms, group them first. So do you look for a pattern? We can group these 2 and these 2. Now if we do so, then here, what is the common factor? X square. So we'll take x square. So this is equal to x square, and when you take x square as your common factor, you're left with x plus x square divided by x square is just 1 plus, so we got x plus 1, which is same to this. So let's put that into a group. Now, as you saw earlier, we got these 2 as common. So we can take or factor x plus 1 out, x plus 1. And you are left with x square from here plus 1 from here. So that's how we factor a polynomial in which there are how many terms? 4. And we could factor it by grouping. Okay? Let's take another example. 12a square minus 6a minus 8ab plus 4b. Now, in this example, Let's do similar kind of grouping. This and this. So what we did? There were 4 terms in our polynomial. We grouped 2 together because we saw a pattern, right? Here we could see common factors, and here also we can see common factor. 4 is common factor there, correct? Yes, 6 itself is a common factor here. So this polynomial can be written in the factored form. Let's try to do it. 6a, both are common for these two. So we'll take 6a, open the brackets. When you divide 12 by 6, you get 2. And a square by a, you get a. Minus 6a divided by 6a is just 1. Minus. Look here. In this example, we are taking minus 4 outside the brackets as a common factor. So when we take minus outside, the signs reverse. So minus 8 divided by minus 4 will give us plus 2, correct? So we get 2, or b is also common. So let me put b there, right? 2a. Now, when you divide plus by minus, what do you get? Minus. That's important. 4 divided by 4, 4b is there, so it's just 1. So what we were looking for, actually what technique we used was, do you see these two common? So we tried to group them so that we get another common factor, correct? Now we can take 2a minus 1 common, and we are left with 6a minus 4b. How do we get it? We get 6a from here, minus sign from there, and 4b, right? So that is how we factor. Now, as you can see, in the process of factoring, it is not always just one step. There could be more than one step involved. And in the process, what do we see at the end? Now, if you see the factored form, then what is common between these two? Nothing but 1 or minus 1. So, at the end, what do we get? We move from sum to product form, and at the end there are no common factors, and we can have more than one step in the process of factoring. This process of factoring is very, very useful. It helps to solve equations, and we will see soon in the next video how to solve application problems using factoring. Okay? I hope you understand the technique. Try some examples on your own. Let me give you some examples here also. You can try this. ax minus ay plus zx minus zy. You see a pattern, so you can group very easily and then figure out what do you get after factoring. Last example, 5x minus 10y plus 3x minus 6y. So that becomes question 4 for you, and this is question 5. Try this out. If you have any problems, get back to me. We'll give you some more practice problems. Okay? Thank you.